Let us revise number systems. Natural numbers, which are also called as whole numbers, start from 1. After 1, the next natural number is 2. After that, it is 3. After that, it is 4. And there are such infinite natural numbers. Now, this set of natural numbers was modified by adding 0 into it to get set of whole numbers. So, set of whole numbers contain all the natural numbers and a 0. Integers. Whole numbers are further edited, or the set of whole numbers is modified to get set of integers, where we add numbers which are smaller than 0, which are negative numbers. There are such infinite negative numbers. So infinite negative numbers 0 and infinite positive numbers, they form set of integers. Now if part of an object we have to show, then that can be done with the help of rational numbers. Numbers which can be written in the form of P upon Q, where P and Q are integers and Q is other than 0. Such numbers are called as rational numbers. Now let us try to represent these numbers on number line. This is our number line. These are natural numbers, and this arrow indicates that there are infinite natural numbers. So we represent natural numbers on number line. When we add 0, this becomes set of whole numbers. If we add numbers smaller than 0, this whole is now set of integers. And if we write numbers in between any two natural numbers, whole numbers, then we get rational numbers. This is 1 upon 2. If we write here 3 upon 2, that is also rational number. So 1 by 2, 3 by 2, these are rational numbers because these numbers in numerator and denominator are integers, and number in denominator is other than 0. Now let us start with our chapter, and the name of chapter is rational numbers. In mathematics, we frequently come across simple equations to be solved. For example, the equation x plus 2 is equal to 13. X plus 2 is equal to 13. We have to find out value of x such that LHS and RHS are equal. So here we can find out that if x is equal to 11, 11 plus 2 is 13, and left hand side and right hand side values are equal. 11 is a natural number. So solution of this simple equation is a natural number, but that cannot be always a natural number. Here we have one more equation, and that equation is x plus 5 is equal to 5. So here value of x must be 0 because 0 plus 5 is equal to 5. But now this 0 is not natural number, and solution of this equation is a whole number. Now let us consider one more equation. Here we have x plus 18 is equal to 5. I have 18 rupees, and how much amount should I add to get rupees 5? Is it possible? No. I don't need to add amount in that. I have to spend some money from that. So if I spend 13 rupees, Means if I add minus 13, then answer is 5. Now this is not a natural number, this is not a whole number, and the solution of this equation is integer. Now one more equation. Here we have to transpose this 2. 2 is multiplying on this side. So to get value of x, let us transpose this 2 and it will perform opposite operation. Opposite of multiplication is a division. So for x is equal to 3 by 2, 3 by 2 into 2 will give us answer 3. Solution of this equation is not a natural number, not a whole number, not an integer. It is a rational number. Also, solution of this 5x plus 7 equal to 0. That is, let us transpose 7. Here 7 is added to 5x. Opposite of addition is subtraction. Now we will transpose 5. That will divide, because opposite of multiplication is division. This is again a rational number. So the numbers in the form of numerator and denominator, where number in numerator and denominator are integers, denominator is other than 0, such a number is called as a rational number. Properties of rational number. Closure property. Let us check closure property for whole number. Now, what is a closure property? If we add two whole numbers, 0 is a whole number, 5 is whole number, answer is 5. These two are whole and their addition also results in a whole number. So we say that whole numbers are closer under addition. Take any two whole numbers. Let us consider 5 and 2. If we add them, 5 is whole number, 2 is whole number, and their addition 7, which is also whole. So whole numbers are closed under addition. Means addition of two whole numbers is also equal to whole number, so whole numbers are closed under addition. If we subtract two whole numbers, 7 minus 5 is equal to 2, but 5 minus 7 is minus 2 and the result is not whole number. Therefore, whole numbers are not closed under subtraction. Here if you change the order, 2 plus 5, that is also 7, which is a whole number. Therefore, whole numbers are closed under addition. But here if we change order, the answer is not whole in case of 5 minus 7. So for any two whole number, subtraction may result in whole number or it may not result in a whole number. So we are not sure about subtraction. So whole numbers are not closed under subtraction. They are closed under addition but not closed under subtraction. Now let us find out closure property for multiplication. 7 into 5 is 35. 3 into 2, 6. 7 into 8, 56. 0 into 3, 3. 3 into 7, 21. Observe, these all are whole numbers. Therefore, whole numbers are closed under multiplication. Now division. These two are whole numbers, but 5 divided by 8, answer is 0.625. Now which is not a whole number. Therefore, whole numbers are not closed under division. Let us revise. Whole numbers, closed and not closed. Whole numbers are closed under addition and multiplication, and they are not closed under subtraction and division. Now let us check for integers. Two integers, addition of two integers is integer, therefore integers are closed under addition. Subtraction of two integers is also integer. -6 is an integer, +5 is an integer. Their addition answer is -1, which is again an integer. Is it an integer? Yes. Now -7 -5, -7 plus -5, that is -12, which is again an integer. So take any two integers, their addition is again an integer, so integers are closed under addition. Now let us find out difference of these numbers. Consider any two integers. -6 minus 5 is -11. -7 minus -5, this minus of minus becomes plus. -7 plus 5 is -2, which is a integer. This is integer, this is an integer. So addition and subtraction for integers will give you integer again. Now multiplication. Multiplication of two integers is again integer. 5 and 8 are integers, their multiplication is 40. -5 into 8 is -40, this is also integer. 5 into -8 is -40, and -5 into -8 is +40. So product of any two integers give you integer, therefore integers are closed under multiplication. But these are two integers and 5 upon 8 is not integer. It is, as we have calculated, it is 0.625, which is not integer. So integers are not closed under division. Let us summarize this. Integers closed and not closed. Integers are closed under addition, subtraction, multiplication, and integers are not closed under division. Now same thing for rational numbers. Consider any two rational numbers, their addition is again a rational number, their difference is a rational number, their multiplication is a rational number, and their division, if we divide by 0, then it is not a rational number. So rational numbers are not closed under division, but rational numbers are closed under multiplication. Rational numbers are closed under subtraction, and rational numbers are closed under division. So it is like integers closed under addition, closed under subtraction, closed under multiplication, but are not closed under division. So same is true for rational numbers. Close, not closed, close, not closed. And these are the systems. Whole numbers, integers आणि rational numbers. Rational numbers closed under addition, subtraction, multiplication and not under division. Integers are closed under addition, subtraction, multiplication and not division. Whole numbers closed under addition, not closed under subtraction, closed under multiplication and not closed under division. Natural numbers closed under addition, not closed under subtraction, closed under multiplication and not closed under division.